Hello. Today we're just going to be having a very quick look at reviewing simplification of surds. I'm going to show you the method that I use for simplifying surds down, and then we're going to look at some examples of times that you could be required to use this. We're going to go over again some of the ideas surrounding how surds work and how they act like pieces of algebra. So just a reminder of what a surd is. Here I've got two things that I'm being asked to square root. I've got the square root of 16, I've got the square root of 32. Hopefully you should instantly recognise that 16 is a square number, and so I can square root 16 easily. Remember, square rooting is a process of trying to work out what number did I square to get this thing here, 16. So what number did I square to get 16? That number is 4, because 4 times 4 gives me 16. So this here is not a surd, square root of 16, because it can be easily square rooted and gives me an answer of 4 or minus 4. And we'll look at the idea of square rooting and getting a negative in a bit more detail when we start looking at quadratic equations again. Square root of 32 can't be nicely square rooted, so this here is a surd. What we can do with this though is we can simplify it. Now there are a variety of different ways of simplifying this. I'm going to show you the way that I use, which is using a prime factor tree. So if I write the number 32 here, I'm going to start breaking this down. So 2 times by 16 will give me 32. I'm going to circle 2 because it's a prime number. I'm going to keep going. 2 times by 8 will give me 16. Again, I'm going to circle 2 because it's a prime number. And I've got 4 times by 2, circle 2 there. And then I've got 2 times by 2, which will give me the 4. Circle those. Now, it's not necessarily the most common way of doing this. A lot of textbooks will go with the idea of trying to think of a square number that goes into 16 and then writing it as that number multiplied by something else and so on. But I find this way helps eliminate any kind of guesswork that needs to go on, because it doesn't matter which way you approach the idea of breaking a number down into its prime factors, you will always get the same prime factors for any individual number. So 32 will always end up with 5 2's. Now what you do from there is you look for pairs, because if I've got a pair of things multiplied together, I can square root them. So for example, if I've got 2 multiplied by 2, I'm just going to cross those two out. 2 multiplied by 2 gives me 4, and I can square root 4, it gives me an answer of 2. So here we're going to put the number 2 on the outside. So every time I have a pair, I'm going to put that number on the outside. So I'm going to cross the pair out and put that number on the outside. 2 times 2 is 4, I can square root 4, it gives me 2, so that's going to come outside the surd. And carry on in the same fashion. I'll use a different colour here just to illustrate that a bit more. I've got a pair of 2's here, doesn't matter which pair of 2's I use. There we go, cross those two out. So 2 times 2 is 4 again, I can square root 4, that takes another 2 outside. And then I've got a single 2 left over, so that can't be square rooted nicely, and so that remains inside the surd. So I've got 2 multiplied by 2 multiplied by the square root of 2. 2 multiplied by 2 multiplied by the square root of 2. Now we can simplify this, because 2 times 2 outside the surd we can do, that's 4. So the square root of 32 will simplify down to 4 square root 2. Now as I say, there are other ways of doing this, but this is my preferred way because it takes any of the guesswork out of what you're doing here. I am going to there it is, just grab my calculator and show you. If you used a calculator and you asked your calculator, I'll just put light on so you can see this. If I asked my calculator to work out what the square root of 32 is, the first thing it would tell me is it in simplified form. So there we go, it simplified it down to 4 root 2, which is exactly what we got there, 4 square root 2. You can obviously then use the S to D. I think this is stuff turns into decimals. These are the stuff turned into decimals, it changes it to 5.65 and so on. Now this is rounded to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. However, it's a reasonably good approximation of the square root of 32 to 9 decimal places at least. And if I were to multiply 5.6568 so on by 5.6568 so on, I would get approximately 32. But the accurate exact answer is 4 square root of 2. Now we're going to use this same technique here with some of the questions that we've got below. We've got 3 worked examples to look at, so this is just going to be a very quick and short video just so we can go through those. So if I move this up, and let's have a look. So simplify square root of 40. Again here I'm going to write the number 40 out, and I'm going to break this down using my prime factor tree, so I can think of this as 4 multiplied by 10. 4 will be 2 times 2, and 10 will be 2 times 5. Circle all those ones up because they're all prime. So remember now I'm looking for things that pair. So here I can see a pair of 2's, so it means that I'm going to have 2 on the outside of the surd. I've got a 2 and a 5. There's nothing that either of those will pair with. I've only got 1 2 and I've only got a single 5, so that means that 2 times 5, which is 10, remains inside the surd, so this becomes 2 square root of 10. So the things that pair cancel, I cross them out because 2 times 2 is 4. That will square root nicely, give me a 2, so I can square root this part nicely, but I can't square root this part nicely. So the 2 comes outside, the 10 remains inside the surd. The next question here is an example of how surds act like algebra. So you can kind of think of this as being like 3x multiplied by 5y, and if I had something like 3x multiplied by 5y, you would multiply the numbers together to give me 15, and then the x times the y would give me xy. Works exactly the same here, just with the added caveat that we can't combine xy to get some singular term, but here we can combine the square root of 10 and the square root of 2 to get a singular term. So here 3 times 5 will give me 15, and the square root of 10 multiplied by the square root of 2 will give me the square root of 20. So we can multiply surds together in this way. Square root of 10 multiplied by the square root of 2 is the square root of 20. Notice, however, that we can't multiply these two together. Rational numbers and irrational numbers are two different types of number, and we can't combine them really nicely. We can combine irrational numbers, surds here, square root of 10 times by the square root of 2, and we can combine the rational parts here, so 3 times 5 gives me the 15, but then you can't combine them nicely from there without writing, say for example 15 as the square root of 225 first. Anyway, we're going to continue with this question. We've got 15 square root 20. Now 20 we might look at and think that's a reasonably large number. I wonder if we can simplify that, and the answer would be that yes, we can. So if I write this here as 20 and I start breaking it down, 10 times by 2, circle that 2 up, and then 2 times by 5, circle those up. Astute amongst you should notice that there's a 2 there and a 2 there, so I've got a pair of 2's, which means that I can bring 2 onto the outside. So I've got my 15 there from before. I've now got my 2 comes outside here, and I'm left with a 5. I'll do one final step for simplifying this. 15 times 2 is 30, so it becomes 30 square root of 2. On to the next one. This here says expand and simplify. So we need to expand this here. So we're going to do the square root of 3 times by the square root of 6, and the square root of 3 times by 2 square root of 12. So that's going to give us square root of 3 times 6, 18, plus 2, because it's like having a 1 in front here that we don't write in. 1 times by the 2 will give me the 2 out the front. Square root of 3 times square root of 12 is the square root of 36. Now again, both of these are reasonably large numbers. Hopefully you should notice that 36 is a square number, so this here will square root really nicely. So actually what we can write here is plus 2 multiplied by 6 at the end here, because the square root of 36 is 6. So we've got 2 times by 6 here at the end. Square root of 18, we need to simplify that down. So again, just down here where I've got some space to do some working, I'm going to write my 18 out. It's going to be 3 times by 6, and then 2 times by 3. Again, I've got a pair here, a pair of 3's, so that means that 3 can come outside the surd, and the 2 remains inside the surd. So square root of 2. So this becomes 3 square root 2 plus 2 lots of 6, which is 3 square root 2 plus 12. So 3 square root 2 plus 12. So this should hopefully give you a helping hand with the second set of exercises that are on SharePoint on the Maths Watch worksheets. Have a go at them, see what you can do. The next video will be about rationalising the denominator. We're going to look at rationalising the denominator when there's a single surd on the bottom. We're also going to look at rationalising the denominator where there is a mixed number on the bottom with rational parts and surd parts, and so we're going to look at conjugate pairs and how we can use those. But that's for next time. Have a go. If you have any questions, drop comments on the questions on MathsWatch, or drop me an email and I will give you a helping hand.